today's problem from number theory, and the problem had three parts, A, B and C. And the first part is if GCD of A, 35 this is equal to 1, so that A to the power 12 congruent to 1 mod 35. Okay, and we use for all part of this problem use the Fermat's theorem, which states that P be a prime and A is a number which is not divisible by P. Then this theorem states that A to the power P minus 1 this is congruent to 1 mod P. And we also use here two property of congruence. This is two simple property, A congruence to B mod n, then A to the power n congruence to B to the power n mod n, and if A congruence to B mod n and C congruence to D mod n, then AC congruence to BD mod n. Okay, now we start from the problem A. Since GCD of A and 35 this is equal to 1, and we know that 35 this is equal to 5 into 7. 5 and 7 both are prime. So we can write GCD of A, 5 this is equal to 1, and GCD of A, 7 this is equal to 1. And this result gives 5 does not divide A, and this result gives 7 does not divide A. And since 5 is a prime, also 7 is a prime, so we can use here Fermat's theorem, or it is said that Fermat little theorem. And using Fermat theorem we can write the result from here. This is A to the power 5 minus 1 this is congruent to 1 mod 5. Okay, and from here we can write A to the power 7 minus 1 this is congruent to 1 mod 5. That is A to the power 4 congruent to 1 mod 5, and A to the power 6 this is also congruent to 1 mod 5. Okay, sorry, this is not mod 5, this is mod 7, and also this is mod 7. Now if we take A to the power 4 to the power 3 congruent to 1 to the power 3 mod 5, and then we get the result A to the power 12 congruent to 1 mod 5. And similarly, squaring both sides we get the result A to the power 6 to the power 2 congruent to 1 to the power 2 this is mod 7, that is A to the power 12 congruent to 1 mod 7, right? And for this result and this result we use this property. Okay, now since these are same, and here this is mod 5 and here this is mod 7, so combining both of them result we can write A to the power 12 congruent to 1 this is mod of 5 into 7. Why 5 into 7? Because 5 and 7 are prime to each other. Then we can write this is 5 into 7. So we can write A to the power 12 congruent to 1 mod 35. Okay, and this is our first proof. In the second problem, it is given that GCD of A, 42 this is 1. We have to show that 168 which is equal to 3 into 7 into 8 divides A to the power 6 minus 1. And here since 42 this is 2 into 3 into 7, so we can write this result by splitting into 3 terms. This is GCD of A, 2 this is 1, GCD of A, 3 this is 1, and GCD of A, 7 this is 1. And we use here Fermat's theorem as we use in case A. This result can be written as A to the power 2 minus 1 congruent to 1 this is mod 2, A to the power 3 minus 1 congruent to 1 mod 3 and a to the power 7 minus 1 congruous to 1 mod 6. So we get three results. The first result is a congruous to 1 mod 2. Second result is a square congruous to 1 mod 3, and this result is a to the power 6 congruous to 1 mod 7. Okay, and from the first result we can write this is a cube congruous to 1 cube means 1. This is also mod 2. And from here we get a to the power 6 congruous to 1 to the power 3. This is 1 mod 3, and this is same. Okay, because we get a to the power 6 congruous to 1, and also here we get a to the power 6 congruous to 1. Now from here it is clear that a cube congruous to 1 mod 2, this means a cube in the form of 2k plus 1. Because when we divide 2k plus 1 by 2, then its remainder 1. Okay, where k be any integer. Now if we take square on both sides, we get a to the power 6. This is 2k plus 1 whole square. And this is given by 4k square plus 4k plus 1. Now taking common 4 into k plus 1 from first two term, this is plus 1. And since k into k plus 1, this is the product of two consecutive integer. Two consecutive integer. Okay, so this must be divisible by 2. We know that product of n consecutive integer is divisible by 2, or it may be divisible by factorial 2, and factorial 2 means here 2. Okay, so this term is divisible by 2, and here a 4 present. So we say that 4 into k plus 1 must be divisible by 8. Okay, so we write the result as a to the power 6 minus 1. This is 4k into k plus 1, and this can be written as a to the power 6 minus 1 congruous to 0 when we take modulus or mod 8, because this term is divisible by 8. And this result gives a to the power 6 congruous to 1 mod 8. Now we take this term of this relation and this relation together and get the result as a to the power 6 congruous to 1 mod of 3 into 7 into 8. 3 into 7 into 8. And it is given that 3 into 7 into 8, this means 168. So we write that 168 divide a to the power 6 minus 1. Okay, very interesting proof using Fermat's theorem. For last part C, here it is given that GCD of A, 133, this is equal to GCD of B, 133, this is equal to 1. And we know that 133, this is given by 19 into 7. And so by using similar argument, we can write from here, this is GCD of A, 19, this is equal to GCD of A, 7, this is 1. And similarly from here, we can write GCD of B, 19, this is equal to GCD of B, 7, this is also equal to 1. And now using Fermat theorem, we can write this is a to the power 19 minus 1 congruous to 1 mod 19, that is a to the power 18 congruous to 1 mod 19. Okay, similarly we get from this result, this is a to the power 7 minus 1 congruous to 1 mod 7, and this is a to the power 6 congruous to 1 mod 7. So we get a to the power 6 whole to the power 3 congruous to 1 to the power 3 mod 7. Now this is a to the power 6 to the power 3. This means a to the power 18, and the right side is 1 cube, that is 1. So combining these two results, we get the result a to the power 18 congruous to 1 mod 19 into 7, and this is mod 133. Okay. Similarly, using the relation of b, we get the same result, b to the power 18 congruous to 1 mod 133. Okay. Now we know that using this type of relation, we get a congruous to b mod m and c congruous to d mod m. Then we can get another one property of congruence. This is a minus c congruous to b minus d mod m. Okay, we use this property here, and simply we write a to the power 18 minus b to the power 18 congruous to 1 minus 1. This is mod 133. Okay, so we get a to the power 18 minus b to the power 18 congruous to 0. This is mod 133, and clearly from this result we can write 133 must divide a to the power 18 minus b to the power 18. Okay, and this is our proof. Very simply we prove the last result of this problem. Thank you for watching.